that equation wrong. Yeah, this is only the passing students. I didn't say there were 760 passing students. I said there's 760 total, so I got to add these to these. Now that's right. And now you solve that like always. 4x, you add 40, 800. X equals 200. So that means 200 students failed. How many passed? 3 times 200, 600 minus 40. All right, 3 times 200 is 600, minus 40 is 560. What's 560 plus 200? Thankfully it is 760. I can check my work. Do I get the total number of students I'm supposed to? Yes, thank God. This is true? No, obviously not. I just made these numbers up. But yes?
Can you work on the sum from number 2 and 4?
All right. Were there any specific ones in number 2 that gave you trouble? Were there? Or F? 2F. Oh yeah. The minute I put fractions in anything, people go running. The beautiful thing about fractions inside of equations is you can kill them. If they're inside of an equation, you got more stuff you could do. Because you got 2 sides that balance you out. So F. So you don't have to. You can get LCD, combine these, and then cross multiply. That would totally work. You guys see that? You don't have to get rid of the fractions immediately if you don't want to. But if you want to, you can always do this. This being what? What can I do to work towards killing all my fractions?
Divide by 30.
Yeah, so my LCD is going to be 30. So if I can make all of these have a 30 on the bottom, I can then multiply by it, and it's going to cancel. Just like that 4 earlier, right? So what does this guy need? 10 to make it 30. This guy needs 2. This guy needs 3. So now I got 20x over 30 minus 8x over 30 equals 21 over 30. And now if I multiply by 30, all my 30s cancel. And now what does the equation look like? 20x minus 8x, 21. Now that looks so much better. But again, I'm not going to count you wrong. In fact, I'm going to get a little tear of joy that if you just put these together and then cross multiply, great, it's fine. Does that mean I like that way better? No, this way is awesome. Kill the part of the problem that is where people make mistakes. That's smart. That's clever. People make mistakes with fractions. Let me kill the fraction. There you go. It's smart. That's what I do. And then you can finish that. And number 4? Yeah, number 4. Good old number 4. I got these on my answer key here, so let me see. Did I give you any like that? No, okay. So I won't do that to you. So if I had this, what you got? Oh, shit. So this could be some equation in economics that's, I don't know, the guaranteed rate of return and the months and the whatever. Who knows what that is? It's just it's actually just something made up. But how do I start to solve this for D? What would I do? What's term? How many terms are on this side?
4.
No.
Oh.
2. 1. 2.
Oh, MX.
Well, no, it's not really MX, but terms are separated by plus and minus. So there's 1, 2 terms. Which term has the variable that I'm looking for? The first one. So which term do I want to get rid of? Second. Always. You find where's my variable, get rid of the other shit. That's your first step. So what am I going to do then? What's my first step going to be? Add B. You got G plus B equals M times D plus C. Now here we got 2 different things I could do. What do you guys think? What can I do here? Where's my variable is stuck inside here. So there's 2 different things you can do right now to take care of that. One is the classic thing you do for equations, which is awesome. Do that. Distribute. So what do you get? G plus B equals MD plus MC. Squared. No, that's squared. And now I do the same thing. Which term has my variable in it? This one. So let me get rid of the other term. So what do? Subtract MC. Get out of here, MC. Too legit. Out over there, get MD. And now you're 1 step away. Divide by M. I love it. So if you do enough of these, you start to realize there's a very definite pattern to how these work. So D equals this business. Can I just cancel these M's out? I kind of gave it away the way I asked that, but because that's not the only thing being divided by M. That's being divided by M. That's being divided by M. So I could do G over M plus B over M minus C, because the M's would cancel in that last one, but I can't let these guys escape being divided by M. That's not fair. Yeah.
After that, please B and number 4, because that's the one that really confused me.
Oh,
3Y.
so that one is exactly like the one we just did.
When I distributed the Y.
I was trying to solve for M, right? Yeah. For M. So yeah, distribute, I like it. What do you get here? 6Y, I like it. So where's your variable that you're solving for? Here. So what are you going to get rid of?
Add 6.
Good. Add 6Y. What's A plus 6Y? A plus 6Y. I love it. And last step.
D divide by 3Y.
Yeah, because you're trying to solve for M.
Okay.
And M is being multiplied. Yeah, it's being multiplied by 3Y, so you divide by 3Y.
Okay.
Now just to go 1 step further, so if you do this, you're perfectly fine. You can stop right there, right? But just to show you, you could say M equals A over 3Y plus 6Y over 3Y. Because both of these are being divided by 3Y. And what's 6Y divided by 3Y? 2. I want to show you that because that's what I got on the answer key. But if you got this, you're fine. These are the same thing, just rewritten.
For
2B?
2B, 2D.
2D, yes?
I tried to do it myself, but I didn't get the answer. So, the Z's or D's cancel out.
All the Z's cancel, yep.
So the answer just fine.
No. So let me do this. Let me go ahead and give you guys the answer key. I'll let you under this. You didn't just get 5, did you? You got 0 equals 5.
0 equals 5, yeah.
Is that true? Is that ever true? No. So there's no solution.
You just put no solution.
You just put no solution. Don't just circle 0 equals 5. That'll make me worried. 0. For very large values of 0, it's equal to 5. No. Yep.
For number 1, does it matter which one we put first?
No. So you said negative 3x plus 3y, you're fine. As long as the 3x is negative. So, remind me, how do I graph this? What kind of line would that be? The graph, I told you graph this in an XY plane. What kind of line is that? Yeah, vertical. Because if I don't let x change from -2, then it's always got to stay -2. So even whatever y does, x must remain -2. Why can y do whatever the hell it wants to? Because it's not even in my equation. I have no constraints on the y. Y, go crazy. But x, you've got to freaking stay here. So y is like, and x is like, oh shit. So it's going to be this kind of a line. So what's the y-intercept?
None.
Yep, good. There's no y-intercept because it's parallel to the y-axis. So for this kind of equation, there won't be an x. Obviously, there's an x-intercept, but there's not going to be a y-intercept. There's no way for it to intersect that because it's parallel to it. It's not going to come over to it and hit it. So I have a problem, y equals, so well, that's not going to have any x-intercept because it's going to be horizontal. It can never hit the x-axis. So it's only going to have a y-intercept. So those are special cases. The y equals the number, the x equals the number. They're special cases. So they're kind of freaky. What's the slope of this?
Undefined.
Yeah, good. Undefined. Because it only rises. The run is always going to be 0. Something divided by 0 is undefined, or sometimes we call this infinite slope. Schwang. Yeah, holy shit.
It's just the y minutes to 0 slope.
0 slope. Exactly. That's nice. Physically makes sense. 0 slope, flat. This is insane.
For number 9, it's always y-intercept. I mean, it's always we have to put y away, like full y.
How do you mean? Say again.
For number 9,
Yes?
it's always y-intercept. It's always. I mean,
How do you mean? Sorry.
that because I tried to put x the other side
Oh.
of the equation. So
All right,
what's
we
gonna
can get
happen?
into an interesting discussion about. We could have made everything in terms of x, but then it would have been run over rise instead of rise over run, for example. But truly, there's nothing wrong with doing this. We just chose this to be the standard way of doing it. Yeah, but if you do this, then this would be the x-intercept, right? So we just said, no, we won't do it that way. We'll just always do it this way, so there's not confusion.
So it's not going to be the same thing.
Yeah, but
right?
when you get further along in math, it's not going to be y and x, so it doesn't matter which way you go, right? It just depends on the problem, yeah. So just to remind you guys, on number 6, I did the slopes for part B using the y2 minus y1 thing, but you can just count on the graph, because you graph the points anyway. You can just count on the graph and see what the rise and the run is for that kind of problem. feel so bad that I ruin your day so much. So look on your face, you know, like, I woke up this morning so happy, then I remembered I had to come here. Aw. It's the life I chose. Yes?
On the E portion of the word problem,
5B? 5B? The triangle one?
yeah, the triangle, is it not equal to anything?
Oh, so that one, we talked about this. Remember, all the angles in a triangle have to make, when you add them together, you get, oh shit. When you add all the angles in a triangle, they have to make how much? 180. In fact, if I said, I got a triangle, let's say 30, 60, 90. A lot of you guys, hopefully you've taken geometry somewhere. 30, 60, 90 triangle. That's the type of triangle. 30 plus 60 plus 90 is 180. So if I change one of the angles, then another angle is going to get bigger. That angle is getting smaller, but the other angle is getting bigger. So they always come out to be 180. Another way to think about it is, this has 90, 90, 90, 90, 360. And a triangle is cutting that in half. So it's going to have a 180. At least in the geometry we use. But don't worry, we'll stay with our geometry, not some freaky ass geometry Jeff learned about. Yay, Jeff, what? Yes.
There is a lot of I know, but as for the finals,
Yes.
will you be giving us?
Practice final, sure. With the answer key, yeah. I'm starting to wonder if I should give practice tests anymore at all, because more and more students, I think more and more teachers, I don't think I do this too much unless it's very basic problems, but a lot of teachers are making practice tests, and then the actual test looks exactly like the practice test, which to me is bullshit. Or are you really learning anything, or are you just knowing what to give back? That's crazy. So when you do study a practice test, just realize it's the concepts on this that are important. Do you understand what slope is? Do you know how to get it? Do you know how to use it? Not, do you know this problem? That's crazy. So yeah, I do give a practice final with an answer key, but just remember, it's really the way I do this is if you do this whole thing and you don't get anything wrong, then you should understand the concepts well enough to attack the problems I actually do give you, right? But it kind of gives you an idea of where to go back and focus when you're studying. You're like, I totally forgot what the hell that is. Let me go back to that section. This semester has been especially bad with students with wrong expectations. And it pisses me off. More and more teachers are making things way too easy, and then they come to me, and I'm the bad guy because I'm trying to make people understand shit. Yeah. For you guys, this one it's going to look very similar because there's only so many ways I can make solving equations look, right? But the questions I ask you about slope or the word problems I give you won't necessarily be the same as these. Yeah. Yes. All right. So both of those are inequalities. So those are ones I'm going to want you to graph. So solving these are just like solving equations. So the first thing I'm going to do here is how do you solve this equation? How do you get x by itself?
Minus 1.
Yeah, minus 1.
Or then divide 2.
Divide by
Negative 2.
-2.
Then you get -2.
What goes in the middle?
How do you know, to switch the...
All right. So that's because, I love this answer. It's because that's how it works. Because again, never forget this example. Which one's bigger? 2. If I divide by -1, this becomes -2, this becomes 1. Which one's bigger now? 1. What happened? They change the side of 0 that they're sitting on. So the order they were in is now changed. And what designates order in this statement? The inequality symbol. So that's how all numbers work. And what's x? It's a number. I don't know it, but it's a number. So it's going to act just like any of the numbers. So when I divide or multiply by negative, that has got to switch. Because the order they were in changes. Cool. Yes?
So if there is a line
Oh.
on the side, then we just fill it in.
Yeah, so this graph would look like this here. So you're going to put an open circle and then shade down. So if it would have been less than or equal to, I would have just shaded the circle in also. Because what's the shading mean? What does this shading mean? What's that mean? That's what the direction means, but what's the shading actually mean? Is there a ghost? Oh,
All the numbers.
freaky. Okay, sorry. The door just suddenly decided to open. Alright.
All the numbers.
Yeah. I'm shading where all the answers are. Is -2 an answer to this statement? Is -2 less than -2? No. So I'm not going to shade -2 in. So really, I look at an open circle as an unshaded circle because it's not an answer. So if it said this, now -2 is equal to -2, so it is an answer. I'm going to shade it also. So that's why it's open circle versus closed circle. That's what they mean.
The open one is like more like that one.
Yeah, the open one just says this specific point doesn't work. That's all it means, because it's not shading. And I shade where the answers are.
Is it like a starting point?
Yeah, it's like an initial point. So, like for example, -1.9999. No, Jeff, you can do better than that. -2.0000000000000001. That works. And if I kept going my zeros for the next 18 years and then put a 1, that number would still work. So really, the open circle is the best way we have of saying this exact number doesn't work, but the number right next to it works. What number is that one, huh? -2 with an infinite number of zeros and then a 1. That's what that number is.
Will you give us like the formula on
Which ones? Nope. Nope. You gotta know it. And the mx plus b you gotta know. You have to know what m is. You have to know what b is. You have to know y2 minus y1. Just remember rise over run is y's over the other guys. Over x, right? Any guys using the Math Study Center at all? Anybody? Yes? How are they doing over there? They helping out? Okay. Because this is a brand new course, so they should be able to handle all the material in it, but the fact that it's mixed with statistics might freak some people out, because not everybody there can tutor statistics. Yeah. Yes, ma'am.
I have a question about numbers 5 and
2.6. Okay. Yeah, all right. Yeah. So real quick, watch. Is this true?
Oh, no, 65.
65? Okay. Same thing, Okay, just with fractions. Real quick, is this true? Yes. But if I do this, for example, is it still true? But if I change all sides by the same amount, then it's still true. That's the reason that whatever we do to one side, we do to all sides. So the one you're talking about, probably, what gave you trouble is the fraction, maybe?
Yes.
All right, but what? Well, hopefully you guys see that I could just. What do I do first to solve for x? Just kind of forget about the fraction. There's only that one fraction. There's no other fractions anywhere, right? So the first step involves nothing fractional, really. What would I do first to start to solve for x? What would I do first here? Yeah, I'd add 5, right? Jorge, do you see that?
Yes.
Okay. So you get 2 less or equal to 2/3 x less than 4. And now, how do I kill that 2/3? Who knows? Yeah, multiply by its reciprocal. Because I want to multiply by 3 and divide by 2. So I'll multiply by 3 and divide by 2. That's its reciprocal. So multiply everything by 3/2. Cool. So you'll get 3 less or equal to x less or equal to 6. And then you can graph that. So you could have multiplied by 3 at the very beginning. If you want to, it'll still work out. But there's just that one fraction in there. There's no real reason to do that. Some of you guys are looking at me like, let me go. You can go. I don't have you shackled to your desk. But if you have questions, ask them. If you're ready, you can head out. Come kick ass tomorrow. I'll watch. So you guys won't leave.
For x, you just plug a 0 for the 1.
Good.
And that's it.
That's it. You solve it. I didn't really have enough room down there, so I just put the answers. But with the y-intercept, you make x 0. You solve for y. And with the x-intercept, you make y 0. Yeah.
Good. لا كل هنا good. ليه طريقة
Yeah, yeah. Good.
ليه طريقة
70 I got.
All right, keep going. You're doing right. So do the subtract x.
Yes.
Good, love it. And then what do you get? So it doesn't matter. It's going to be a special case, right? When the variable disappears, it's going to either be all real numbers or no solution. So is 4 less than 10?
Yes.
Yes, always. So all real numbers. That's always true.
Oh, I don't have to graph that.
Yeah, that would be weird to graph. You just shade the whole number line. If you had to graph it.
Wait, but it says something. Yeah.
If you had to graph it, you would just shade the